Hi guys, welcome to another physics video. In this case, we're gonna see the second problem about the motion in one dimension. So in this case, we got an airplane. It says that lands with a velocity of 214 kilometers per hour, and it takes 1.6 minutes to finally stop. So find the acceleration and the distance traveled when landed until it stopped. Okay, so in order to do this problem, well, the first thing that I'm going to do here is that I'm going to make the drawing. So imagine that this is this is the track of the airport, okay? And the airplane is flying, for example. Here is the airplane. He's in the air, okay? And he's going to land. And the problem, the problem is it's not this is not the beginning of the problem. The beginning of the problem is when the airplane is in the floor or the ground, when it already landed. So this is the airplane, okay? Of course it lands, but has velocity and is going to move. Remember, if the problem does not say the direction, I'm going to assume that the direction is always to the right. So the direction it's positive. So it's going to move to the right until finally it stops. Let's say that it stopped right here. Okay, that's my airplane. That is completely stopped. I'm sorry for the drawings. That's not my, I'm not very strong at drawing. So this here is the initial position. Here is the final position. Here I got the initial velocity, final velocity, and of course, this is the time that took the plane to finally stop. Okay, so let's say that this is the drawing, and we're gonna start with the problem, but I'm gonna use this whiteboard over here. So I'm gonna write the data. So the initial velocity data, I'm gonna write data. Okay, let's give it 100% the zoom. The data is initial velocity equals 214 kilometers per hour. Of course, the final velocity will be 0 kilometers per hour, because at the end the airplane is completely stopped. Okay, the time is 1.6 minutes. The initial position, I told you that most of the times, the initial position will be 0 meters. The final position, well, I need to find the acceleration and I need to find the final position. Okay, next, what I'm going to do, I'm going to write the formulas that I know. So remember, the first one is acceleration equals final velocity minus initial velocity over time. And the second formula is final position equals initial position plus initial velocity multiplying time plus acceleration times square over 2. Okay, in this problem we're gonna have acceleration, because remember, acceleration is the change in velocity. So of course we're gonna have a change in velocity right here, because right here the plane lands with 214 kilometers per hour, and then it's going to completely stop. So that means that it's going to reduce the velocity. So that means that there will be a change in velocity. If there is a change in velocity, we're gonna have acceleration. Okay, so the next thing that I'm gonna do, I'm going to cross and check mark all the things that I have and I don't have. So for example, in this equation, do I have acceleration? No, I don't have acceleration because I need to find it. Final velocity? Yes, I have it. Initial velocity? Do I have initial velocity? Yes, I have it. And do I have time? Yes. So there is a note, and I want to share with you. If I got two crosses or more in an equation, that means that I cannot use that equation. So I'm gonna repeat it. If the equation has two or more crosses, I cannot use that equation. So in this case, I just got one cross mark, so I can use this equation. So let's write it. So for example, if you see here time, I got it in minutes, and velocity, I got it in hours. So I need to transform those units so I can perform this problem. So the thing that I'm going to do, I'm going to transform this one into meters per second, and this one I'm going to transform them into seconds. So those velocity and time I'm going to have them in seconds, so I can work with them with this formula over here. So let's transform the initial velocity. I'm gonna have 214 kilometers per hour. So I'm gonna use the conversion factor. So kilometer, I want to transform kilometers into meters, so I'm gonna say 1 kilometer equals 1000 meters, and 1 hour is 3600 seconds. Okay, if I do this, I'm gonna cancel kilometers with kilometers and hours with hours. So let's do the operations. I got my calculator over here. So let's see, it will be fraction 214 times 1000 over 3600 equals, that's the answer. And I'm going, this is infinite, this is a number that has infinite number of decimals, so I'm gonna save this value in a memory. Shift STO A, so I got this value saved in the memory A. Okay, so I'm gonna write this number 59.44 meters per second. Okay, and 1.6 minutes, well, I'm just going to multiply them by 60 seconds. So it will be 1.6 times 60 seconds equals 96. So this will be 96 seconds. Okay, after doing that, now I can use this formula over here. Let's do it with the blue one. So acceleration equals final velocity is 0 meters per second. If you see I got kilometers, oh, it's supposed to be kilometers per hour. Okay, but I wrote meters per second. That's because it doesn't matter. In the end, it's gonna be 0. So 0 meters per second equals 0 kilometers per hour. Okay, minus 59.44 meters per second over 96 seconds. Okay, so let's do it in a calculator. So it will be 0 minus the value that I got saved in the memory A. Let's do it with the fraction. 0 minus the value in A over 96 equals, and that is the value of the acceleration. Okay, I'm gonna write here acceleration equals minus 0.6192. What about the units? Okay, listen up. I got meters per second. I'm just writing the units, these units, meters per second, and that's gonna be divided by seconds, because I'm writing this one over here. So I'm gonna write a 1 over here, and I'm gonna use this formula, outside with outside, inside with inside. So meters times 1 is gonna be meters over seconds times seconds is going to be seconds squared. So the units of the accelerations are going to be meters per second square. And that is the first answer. I'm going to circle it with red. And if you see, well, I got an infinite number of decimals. So I'm going to save this number in another memory. This is saved in the memory A. So I'm going to save this value over here in the memory B. So I'm going to do Shift STO and the B of my calculator. So if you see, I got this one. Answer got saved in B. Okay, now I need to find the final position. So let's review this formula that I got here, the second equation. And I'm gonna ask, do I have final position? No, that's the one that I need to find. Initial position? Yes, it's 0. Initial velocity, I got it, is this one. The time is 96 seconds. The acceleration, do I have acceleration? Yes, I just found it. Do I have the time? Yes. Okay, now I can use this equation and I'm gonna cross everything that is 0. So the initial position, if you see 0 meters, so I'm gonna cross it because it's 0. I'm gonna write the equation here. Let's see. I just wanna erase the grid. Okay, so I'm gonna write the equation again, the equation that I'm gonna finally use. Final position equals the initial velocity multiplying time plus the acceleration that multiplies the time squared over 2. Okay, so let's substitute. The initial velocity is 59.44 meters per second times 96 seconds plus the acceleration minus 0.61. I'm just going to use 2 decimals. Okay, minus 0.61, 6192. 6192 meters per second square. That is going to multiply 96 seconds over 2. Okay, if I do this, well, seconds are going to be canceled with these seconds, and second square, and this is, I forgot it, but this is a square. And those second squares are going to be canceled with this second square. So let's do this operation in the calculator. So this value over here, the initial velocity, I got it in A. So it's going to be 96, the time 96, that multiplies the value of the initial velocity, that is A, plus fraction. This value over here, I got it in B. Okay, so I'm gonna write alpha B times 96 square over 2. Okay, this is how I'm doing this operation in my calculator. Maybe your calculator is different, so your operation is going to be different. It is important that you know how to enter the operations in your calculator. So I'm gonna hit the equals button. Okay, so that is the answer in meters. That is the position. That is how far the airplane went. So final position equals 2853.3333 meters. Okay, now those are the answers. But before I finish this video, it is important to tell you, I mean, the acceleration went negative. Okay, what does this mean? Okay, this means, for example, the motion goes in this direction, motion, and also the velocity. But the acceleration is negative, so that means the acceleration goes in this direction. So the acceleration is the force that makes the airplane to stop. Is decreasing, is making the velocity to decrease until finally it stops. So that's why the negative sign. Remember that the acceleration is a vector. This is the magnitude, and the negative sign is the direction. Where does this acceleration go? Okay, it's going against the motion because it's braking the airplane. Okay, and of course the position is positive. So this was the problem number 2 of motion in one dimension. And stay tuned, guys, because we're gonna see more problems about physics too. Bye bye.